Hello, this is section 7, and it is the last section of chapter 2, and we'll be working with division of real numbers. We have two goals for this particular section. We're going to be dividing real numbers, and then we're going to be using that division to also simplify algebraic expressions. We have one rule when considering division. And so we'll go ahead and write this down in your notes along with the examples that you see. The rule states that to divide a number by a non-zero number, we need to multiply by the reciprocal. And so reciprocal, you should know that from back in 7th grade and 6th grade math, and that some teachers might have told you that to find the reciprocal of a number, you're flipping it. But anyway, in order to divide, we need to multiply by the reciprocal. So taking a look at the algebraic model that we have, a divided by b can also be written as a times 1 over b. And that would be 1 over b is the reciprocal to b, or b over 1. So that's where we get the flip part. So in our example here, we have negative 1 divided by 3. That would be the same thing as saying negative 1 times 1/3, which then we know is negative 1/3 when we look at any number that we have times 1 or negative 1 here would be the opposite of what I see. So again, we use reciprocals. If you can remember back, we use them specifically when dividing fractions. So you might remember a former math teacher saying, dividing fractions is easy as pie. Flip the second and multiply. The second thing we need to consider when dividing real numbers is adding in signs, so positive and negative numbers. And they're going to be the same as the ones we had for multiplication. So here they say here that the quotient of two numbers with the same sign will always be positive, and the quotient of two numbers with opposite signs would be negative. So again, you can be thinking back, and if you want to think quickly, you might think that, a positive divided by a positive is going to equal a positive. A negative divided by a negative is equal to a positive. And finally, if I have one of each, and it doesn't matter which one comes first, a negative divided by a positive or a positive divided by a negative will always give you a negative. So let's use our rules and our operational signs to work through some divisional problems. Within math, there's many ways to show division. So in the first example, you'll see kind of one of those traditional division symbols, a line with two dots. So to simply attack this problem, I know that I can use negative 45. And then we say that rhyme again. Dividing fractions is as easy as pie. We flip the second and multiply. So I'm going to change division to multiplication. And then I'm going to take the reciprocal of 5/6, which is 6/5. Then I can make negative 45 a fraction by putting it over 1. And then for me, I like to cancel whenever possible. Okay, we also call this factoring out a number. Does the numbers... And we can see that by knowing that the number 45 and 5, they have a common factor of 5. 5 times 1 is 5. 9 times 5 is 45. So I'm going to divide them by a common factor. So 5 divided by 5 is 1. 45 divided by 5 is 9. So now my problem becomes negative 9 times 6. 9 times 6 is 54. And then a negative times a positive would be a negative. So my answer would be negative 54. On the top, and then 1 times 1 would be 1, so that would give me 1 on the bottom, and negative 54 over 1 is negative 54. So remembering the rhyme of multiplying fractions ain't no problem. Take the top times the top and the bottom times the bottom, and then simplifying your answer. The next problem is another way to show division. Notice here that we have, here's my divisional line that separates a numerator from a denominator. Notice my numerator is a mixed number, 2 1/3. So I want to take 2 1/3 divided by negative 3. Okay, so another way to write that would simply be 2 1/3, and here I'll draw a little squiggly line to separate the two problems, divided by negative 3. That's another way to write the exact same problem. So again, we remember the rhyme. Dividing fractions is easy as pie. Flip the second and multiply. There is one more step though, because I have a mixed number out front here. I need to change that to an improper fraction. So I'm going to do the rules for that. So I'm going to take the denominator of 3 and I'm going to multiply that by 2, and whatever that product is, I'm going to add in 1. So 3 times 2 would be 6 plus 1 is 7. So my numerator is 7. And I'm going to keep my same denominator down here. That was 3, stays 3 down here. So then 2 1/3 becomes 7/3. Now I'm going to switch the divisional sign, divide, and I'm going to change that into times. Now I need to know what is the reciprocal of negative 3, or negative 3 over 1, so I'm just going to flip it. And so that's going to be 1 over negative 3. So we're going to multiply the fractions together. I'm going to first look at diagonal numbers to see if I can cancel, or what we call factor out, and I can't. So then I will look at taking the top times the top. 7 times 1 is 7, and 3 times negative 3 would be negative 9. So my fraction then, my final answer becomes 7 over negative 9, or I can just simply say the fraction negative 7/9, which is simplified. Again, please write down all the work as you've watched me show you, so that you can kind of use it for problems that you do in the future, because that is our expectation in your notes, is to write down the work that we do as well. In our next two examples that you see here, notice we just have expressions, and we don't have all the numbers that we need to actually come up with an actual answer. So the best that we can do is just simplify it and to make it into a number that we can share that is easiest to look at, I guess. So I have two of them. In our first example here, we have 9 minus 27x divided by negative 3. I'm not going to be able to come up with an answer that would be a numeric answer. I just need to simplify this if I can. So in looking at this, there's two ways to do it. We can think about that rule of dividing fractions, okay, knowing again that this is my divisional line right here. So here is my numerator, 9 minus 27x. And what I would probably do there is add op right away, use that and say that's 9 plus a negative 27x as my numerator. So I'd want to take 9 plus a negative 27x, and I want to divide that by negative 3. So the rules of dividing, again, we're going to multiply by the reciprocal. Okay, so that's going to be 9 plus negative 27x, and I'm going to multiply all that by negative 1/3, because that's reciprocal of negative 3 over 1. Now, back in 6th grade, you were first subjected to what's called the distributive property, and you learned even more of it in 7th grade. So what I can do to simplify this particular expression, I can distribute. I can take a look at distributing the negative 1/3 and multiplying that times negative 27x, and then distributing it over the 9 and multiplying it by 9 as well. So that's what I'm going to do. I'm going to take negative 1/3 and I'm going to multiply it times 9, or 9 over 1. And then because I have plus in here, I'm going to add it to here. And so then I'm going to take negative 27x over 1 and multiply that times negative 1/3. Okay? So in looking at these two, I can do some simplifying, I can do some canceling, or what we call factoring out. So in the first one that we have here, I have a 3 and a 9. And I can divide them both by 3. So in doing that, I get 1 and 3. So the first, or the left-hand side here, this part, negative 1 times 3 would be negative 3. And 1 times 1 is 1. So negative 3 over 1, or negative 3. And over here to the right, I'm going to look to cancel. And I have 3 and 27. I can divide those two by 3. 3 divided by 3 is 1. Negative 27 divided by 3 would be negative 9. So now I'm going to take top times top. Negative 9 times a negative 1 is 9. And 1 times 1 is 1. And then also I have this x in here. I forgot, it's negative 9x times negative 1, which is positive 9x. And I'm going to add those two together. So a negative 3 plus 9x over 1 is the same thing as saying negative 3 plus 9x. And that would be the most simplistic way to look at what we started with. In our second example, I'm going to do the process a little differently to show that there's a couple of different ways to do this problem. And the second way that I show you, I feel is a little bit easier to do. The reason why I showed you the longer way first is to show you why I'm able to do what I'm going to do here in this next one. So, for example number 2, I want to simplify 35 times x plus 28 divided by 14. Again, I can only simplify it because I do not know what x is here. So, I'm going to start off with this one being a little bit different. I'm going to rewrite this next one. So I'm going to rewrite this expression a little differently. I'm going to say 35x, and I'm going to put that over 14. Because I see add here, then I'm going to add, and I'm going to put 28 over 14 over here. Now, the reason why I'm able to do this and put 14 over both of these numbers is simply back to the first example where I was able to distribute the 1/3 over both using the distributive property. Well, basically what I'm doing is I'm distributing the dividing by 14 over both right away. So this can kind of help because now it's just a simple matter of reducing fractions. So when looking at our first fraction, 35/14 x, okay, I can see that I can factor out a common factor. 35 and 14 share this common factor of 7. So what I can do is divide them both by 7. So 35 divided by 7 is 5. And 14 divided by 7 is 2. So that's what I did. I divided them both by 7. So then I come up with 5/2 times x. Then what I'm going to do is come and take a look at my next fraction, which is 28/14. And if you see there, again, I have a common factor that I can factor out. Both 28 and 14 have a factor of 7. So once again, I'm going to divide both by 7. So 28 divided by 7 is 4, and 14 divided by 7 is 2. So I'm getting very close to a more simplified answer. Okay, 5/2, okay, is an improper fraction, and I can leave that as that, or I can change it to 2.5 as the decimal, or I can leave it and write it as 2.5 this way. But when you're dealing with algebra and doing with math this year, okay, my suggestion is it's okay to leave this as just simply 5/2 x. But then if you notice here, I can reduce 4/2. 4 divided by 2 is 2. So this would be the simplified answer for the second problem, 5/2 x plus 2. To me, this is the way I would go about it. I would do it like this. But again, you can use a distributive property like I did in the first example. But I just simply showed you that so that I could explain why I was able to put these 14s over these two numbers, or under these two numbers. The final three examples that we're going to do together involve taking a look at an expression, and then now what I have is I now know what the variables are. So here we're going to evaluate knowing when x is -5 and when y is -1. So we're just going to plug in numbers for letters and then solve. So in our first example, we're going to simplify 2y divided by x over 1. So I'm going to plug in for y, I know that's -1. I'm going to divide that by, I know that x is -5 minus 1. So in simplifying that, 2y means 2 times y, so 2 times the -1 would be -2. And then -5 minus 1 more, I'm going to add op. So then -5 plus a -1 would be -6. So we can think about that as a negative divided by a negative was going to be a positive. So that's the first thing. My sign is going to be positive. The other thing you'll notice is I have 2 over 6. Well, I can just think about my final answer as a fraction. The fraction 2/6, I can definitely simplify that into making that 1/3. And it's going to be a positive 1/3 because a negative divided by a negative is going to give me a positive. So my answer here would be 1/3. In my second example, I have 5 plus x divided by 5. So I'm going to plug in, so 5 plus, in this case I have a -5 as being what x is, and I'm going to divide that by 5. So again, order of operations, when you have a fraction, we have to simplify the numerator first, and then the denominator second, and then I'll divide last. So 5 plus a -5 we know as being 0. And then that would be 0 over 5, or 0 divided by 5. And we should know that 0 divided by any number is 0. So my final simplified answer then is 0. In our final example, we have x plus y divided by y plus 1. So plugging in numbers, I'm going to have -5 plus a -1. I'm going to divide that by -1 plus 1. So again, I'll simplify the numerator, simplify the denominator. -5 plus -1 is going to give me -6. And then -1 plus +1 is going to give me 0. Now this is a special case. We talked about in the very first slide about a non-zero number in the denominator. Okay, it is impossible to have 0 as a denominator because it's hard to take any number and split it into nothing. That's basically what we do when we divide. Okay, dividing by nothing. Okay. -6 split it into nothingness is something we can't understand. I can't take something and make it disappear. So therefore, if you have 0 in your denominator, we need to write this answer, undefined. Okay, so whenever you see 0 as a denominator, we can't really relate that to a number, so we just call that undefined. Here are your practice problems for tonight. We have 3 of them. And again, put these at the top of your homework paper to start for tomorrow. Taking a look at these, use our notes that we took earlier today and come up with some answers, and we'll give you the answers tomorrow. Have a good night, and we'll see you in class.